Hey folks, let's give and take. Hopefully you filled out your give and take worksheet here and found out that, hey, there are some interesting things going on here with the different columns. So for instance, group 1 here all has one electron in their valence shell. Their outer shell all has one, so they all want to lose one electron to be happy. Group 2, they all have 2 electrons in their outer shell. Look at that, 2 electrons in our shell. And they all want to lose 2 in order to be happy. And all the way across, group 3 wants to lose 3. Group 4, they can either lose 4 or gain 4. Group 5 wants to gain 3 because they all have 5 in their outer shell. And so forth. Gain 2, gain 1. And group 8 over here is already complete. This one here is complete with 2 in its outer shell. This one's complete with 8 in its outer shell. This one's complete with 8 in its outer shell. Okay, I didn't finish. I only drew through 12, but you get the idea. So what does this tell us? The cool thing about this is that you can then go, hey, if I have a hydrogen or anything over here in group 1, what will it easily bond with? Well, how about anything over in group 7? Because they want to gain 1. Hey, they're like a match made in heaven. It's like having someone over here needs $1. Guess what? Someone over here in group 1 has an extra $1. Perfect. They're a match made in heaven. They create a bond of debt. That's right. So if an electron needs to be gained over here by a fluorine, for instance, it can connect up with any of these elements over here in group 1, and they're going to be happy together. So fluorine can bond with hydrogen. Fluorine could bond with lithium or sodium or potassium and so forth. Any of these work. So for instance, the commonly used example of salt, table salt, sodium is over here in group 1 and wants to lose 1. Chlorine is over here in group 7. It wants to gain 1. They're a match made in heaven. They become NaCl, sodium chloride, table salt. Perfect. So you can actually do this right on your sheet here. You can kind of connect up. Oh yeah, group 2 wants to lose 2. This group here over here, group 6 wants to gain 2. Match made in heaven. Perfect. Group 3 can pair up with group 5. And group 4, I suppose, could pair with itself. However you want to do that. And you have sort of this little rainbow looking thing. Great. Now it doesn't mean necessarily that the only thing that, for instance, oxygen here wants to gain 2, it doesn't have to go over here to something that wants to lose 2. Oxygen could pair up with, say, so like it needs 2 electrons, it needs $2, needs $2. So it could go over here to magnesium, great, or it could go all the way over here and pair up with a couple of hydrogens, because they can lose 1 each. So if you need $2, you can find 2 people that want to give you $1. Hey, H2 can bond with an O. Imagine that. Wada. Great. All right, so we're pretty happy there. We've got this nice, beautiful rainbow to complete our periodic table. What about this group 8 over here that's complete? They have a complete outer shell, 2 in the outer shell here. This one's got complete with 8 and so on. These ones here are complete already. They are what we call the noble gases. Ooh, put a little crown over here. Yay! They are happy by themselves. That's right. They don't interact with anyone. They're like noble people. They're like the king and the queen. They're kind of stuck up. They kind of do their own thing. They're like, you peasants, you peons down here, you can just do whatever you want, bond, blah, blah, blah. We are happy by ourselves. So helium, neon, argon, krypton, all of these gases over here are complete already. So we call this group 8, the far right column over here, is the noble gases. Lovely. All right, there you have it. Bonding in the periodic table laid out pretty handily for your pleasure. Perfect. Hope that helps.